In this section, we're going to take a look at using the Big Query service. So in this service, you can use the SQL query language to perform queries on files that are either stored in BigQuery or in buckets in Google Cloud Storage. It's really important to understand how billing works, and this is from the Markdown page. You're charged by the amount of data that's scanned, and it starts at $5 per terabyte scanned. Now, for several of my clients, they have negotiated buying bulk BigQuery compute capability. And so you need to check for your organization when you're running full production research workloads what your actual rate is. But when you're trying it out, it's $5 a terabyte scanned. And it's important to know that Google provides public reference data sets. The previous movie, I showed you some examples, 1,000 genomes. Of course, this is going to save you money if you're referencing this in your queries. So the interface is a console, and here's a screenshot. And you can see that on the left side, we are referencing some of the genomics public data that's available in BigQuery. And on the right side, in the query editor, we have SQL statements. And notice what's highlighted on the bottom right here. The query will process 1.1 gigabytes when run. Really important to look at this and consider the cost when you're working with BigQuery, because even though it can be a really fast way for you to get information about file-based data, you need to make sure that the costs are in line, and you need to think about how to query the smallest possible subset of data, particularly when you're starting and doing exploratory queries. You don't want to query the whole data set if it's really big, because you'll basically spend too much money. If you're unfamiliar with SQL syntax, it's a structured query language. It's simpler than some programming languages in terms of querying, and so you can learn it pretty quickly. So here's a link to get the basic structure if you're not familiar with SQL. Then you're going to want to, after you decide how you're going to query, this is where you can look at your results. Now notice in the editor, you can just view the results. You can view them as JSON, or you can explore them in a visual interface. This is integrated. It's called Data Studio. Now, you might be used to exploring with Excel charts or Tableau or third-party product, but Data Studio is integrated. It's a Google product. And really important that you want to verify the query cost before you run it. Again, I've said this a couple times, particularly with genomics, where you can be working with some really big files. There have been some unfortunate situations with clients where they didn't understand the cost and they just thought, oh, this is a great tool, I'm going to go ahead and run this, and they ran up some really big bills. So you want to understand costs before you do really large size queries. Here showing you the results, and you can see there's information about the processing here. In this particular query example, we went from 39 million rows, we aggregated down to 25. And we were able to do that in 2 seconds with a 1.1 gigabyte processed. I mean, this really is a powerful service to understand the contents of files. So I think it has a lot of application in genomics, but it's really important to understand how it's built, basically. And then some other things, and again, I just touched on some of the highlights. There is this flag, it's called the dry run parameter, which allows you, if you're working with BigQuery from a script standpoint, using the BQ tool to get a cost estimate before you run a query. Again, super important. And then there's a lot of capabilities of the SQL language. I mean, just the most very basic thing is, rather than getting all the data, which is a select star, select the information in every single column, if you will, of the input data, or everything separated by commas, where you might want to select a subset. So select the first row, the second row, for example. And then I put in this Markdown page a whole bunch of tutorials as well, because again, I think this is a key service on GCP for working with genomic data. So let's actually take a look at how the mechanics of working with this go. So I've got my console open here, and I'm going to be working with some of this public data, and I'm just going to basically count the variance in this public data. So here's the data resources over here, and if I scroll down, you can see here's the human genome variance, and I'm just doing a count the number of rows. Now I've run this already, so it's going to be cached, so it's going to run even faster than normal. But I'm just going to click run, and you can see that it has this number of rows, so huge number of rows, and it fetched the information out of cache, which again is another consideration when working with BigQuery, understanding caching, because that can reduce costs. Now you can save this as a view, so you can save this query and name it, which is useful if you're experimenting and working with a team. Each of these drop-down arrows gives you some capabilities, so you can save the query, you can schedule the query, and you have query settings. So in the query settings, you can use different engines, you can set a destination table, you have the ability to encrypt with your own key if you have some sort of requirement to do that. This is a super important button right here, interactive or batch. You can reduce the cost of the query. Interactive is turned on by default, which is going to return the query results back much faster than batch. But again, understanding the costs, depending on the service selection configuration, is really important. See, by default, we're using the cached results here. So you do want to look at these advanced options. So inside of here, here's my rows, and then I could save my results out to CSV. I could save it to JSON, BigQuery table. I could explore it with Data Studio, and I can actually save this query, which I've done, so it's here. And then I have another query that's more complex using 1,000 genomes. I open that in the editor here, and you can see this is going to process 1.1 gigs, which, as you'll remember, it's $5 a terabyte, sort of the top commercial price. And now if I want to run this query, let's take a look at it. So we're getting the proportion of variants per chromosome in the data set that have been reported in the DB SNP database. So you'll notice that we have some pretty sophisticated ANSI SQL here. So we have the with clause, and then we have a select and a count, and we have a count if here, and then we're doing a group by, and then we're computing the ratio. So, and then we have an order by, so we're sorting it. So let's run that. And here we can see the results. Also, interestingly, we can look at the execution details. And again, if you're looking to optimize really complex queries, we can actually see, for example, if there were bytes spilled to disk, and as with anything in GCP, there is a question mark. You want to, and you don't know what it means, you want to pass your mouse over it, and you can see this is talking about when the query was not able to fit in memory, which is going to affect the performance and possibly also the pricing. So if we scroll up here, we can see that we have the various phases, and this is performing in aggregate again, where we start with 40 million rows, we end up with 25, and we can see the amount of timing. So again, this is something that you may never need to look at, but because I think that in genomics, this is really a service that more and more people are going to be using, I really want to show you some of the tools. This shows you the internal mechanism. And why you care about this is if you wanted to tune the query somehow to make it run more efficiently, either by rewriting the SQL or maybe by splitting up the input data, partitioning it. There's a number of techniques, and I've put a link to this out on the Markdown page. There are a number of techniques you can use to reduce the price of the querying. I just really think this tool is very powerful and very usable because the SQL language is well known, and it allows you to work with a lot of examples that are already cataloged. So there's a lot of queries that are cataloged, and there's a lot of data sets that are already available in the public data sets, not only here in the BigQuery public data, but in some other data sets that some of the big research organizations are making increasingly available on GCP.